I am one of hundreds of physicists that spend their lives looking for dark matter, something invisible, so far not confirmed form of exotic matter. But why? How did something practically invisible become one of the biggest open problems in physics? Well, it's because indirect evidence for the existence of dark matter is everywhere we look. It comes from looking at the bits of the universe that we can actually observe, and specifically how they move under the force of gravity. In this case, to demonstrate, I'm using this piece of rope, which turns the force of gravity of one object into the force that keeps another in orbit. If the rotation's too fast or the force of gravity too weak, then the orbit's not stable and it would fly apart. If the rotation's too slow and the gravity's too strong, then the rotation would collapse. This fine relationship between how an object rotates another and the force of gravity between them is what Swiss astrophysicist Fritz Zwicky used to show something strange about the universe. He looked at the comet cluster, he counted the stars and galaxies in it, and that gave him an estimate of the amount of gravity. Then he tried to balance that with how fast the cluster was moving, only to find a bit of a problem. The matter he could see did not provide enough gravity to support how fast the cluster was spinning. Now, Zwicky was stubborn, and he did not like admitting that he got something wrong, so his conclusion was strange, and it was that most of the matter in that galaxy cluster is actually invisible, but still quite heavy. Invisible in that it does not absorb or emit any light, dark. This dark matter would provide that extra gravity needed to now support that much faster orbit. But everybody thought Zwicky was crazy, and it took over 40 years for some to start changing their mind when Vera Rubin started making similar observations now at the scale of individual galaxies. Not just one or two, but every single galaxy, big or small, young or old, were all spinning so much faster that should have been possible, well, without taking into account some dark matter to keep the system together. Vera Rubin's work was essential in mapping the distribution of dark matter in the universe, telling us there's over 5 times more of it than known matter. Which brings us to today, where we can look at how our own galaxy rotates and estimate how much dark matter is right here, right now. So Fritz Zwicky was crazy enough to spot it. Vera Rubin was smart enough to quantify it. We need to get creative enough to detect it. Thank you very much.